Hi, everybody. Welcome to section 5.2, where we will be discussing integration by substitution. So the learning objectives for this section will be to use substitution to evaluate indefinite and definite integrals. So let's go ahead and look at example 1, where it says evaluate the integral of 18x plus 8 over 9x squared plus 8 minus 3x. So far in this class of integration, we haven't really learned anything that can help us solve this integral. So what I'll say here is we can't we can't solve this, but we will use a method called U substitution. Okay, so we're going to learn a new tool to use to integrate integrals like this. So the first thing we're going to do is identify a u within this integral. So what I'm going to do for this problem is going to let u equal 9x squared plus 8x minus 3. So I'm making u equal this denominator in the integral. And then what I'm going to do next is take the derivative of u. So du would be 18x plus 8. So going back and forth a little bit, I want to integrate, but I need to take a derivative of this u. So the next thing I'm going to do, I forgot something here, but there's going to be a dx attached to the derivative. So the next thing I'm going to do is divide everything to the other side to get dx by itself. So I'm going to divide by 18x plus 8. I'll use a different color. Divided by 18x plus 8. And so the 18x plus 8 cancels out. And what I'm left with is dx equals du over 18x plus 8. So now what I'm going to do, since this is called the substitution method, I'm going to substitute everything that I came up with in terms of u into that integral. So coming back down here, I'm going to have the integral. What this equals is 18x plus 8 over 9x squared plus 8x minus 3 is now u. So it's going to be over u, and then dx equals du over 18x plus 8. So now, if you notice, I can cancel out these 18x plus 8 expressions. So what I'm left with is the integral of 1 over u times du, and the antiderivative of 1 over u, if you can recall previously, is going to be natural log of u plus c. But we aren't done yet because we do know what u equals. U equals 9x squared plus 8x minus 3. So I'm just going to finish this problem off by substituting back in what u equals because we want it in terms of x. So this will be natural log of 9x squared plus 8x minus 3 plus c. And that is our final answer. So this is a new method called substitution. It helps us integrate integrals like these, where we don't really have any tools, but now we have a tool to figure that out. And here's really a suggestion for use substitutions. So when you have a couple scenarios here, if it's a quotient, you'll let u equal the denominator, like we did in example 1. Another option is if there's an exponential expression, you let u equal the exponent. We'll see an example like that. And if a power or radical, we let u equal the base of the radicand. But okay, so that's a little exposure to that. But besides these suggestions, there's always a really process to do substitution. So what I'll write here is process. So step 1 is always pick u. Step 2 is take derivative of u. Step 3 is move everything over to get dx by itself. Step 4 is to plug in u and plug in u and du. Step 5 is to integrate. And step 6 is to plug back in what u equals at the end. So this is really the process with substitution. Of course, there's different variations of what you choose to be u and um, how you move expressions over and etc. But this is basically the same process. And we'll go ahead and look at more examples in the next video. But that's it for this video, and I'll see you next time. Thank you. Bye.